Trying a new recording method for today using my smartboard rather than my iPad. Just going to answer these questions for you about linear functions, and hopefully we don't have any more questions with linears. We'll move on with our review tomorrow. Person drives at constant speed. They drive 107 miles in 2 hours. Then how far will they travel at the same speed in 1¼ hours? Well, let me do it like this. 107 miles in 2 hours is going to be 53.5 miles per hour. And if they're doing that for 1½ hours, 53.5 by 1¼ 66.87. That sounds like 67 miles to me. There's your answer for the first one. Given the function f of x equals x squared minus 2x plus 7. All right, I'll just clear my ink here. There we go. Got some good space to work now. Average rate of change over the interval 3 to 11. If you plug in 3 into this function, f of 3, you're going to get out as a value 9 minus 6 is 3 plus 10. So you're going to get 310. And if you plug in 11 into this function, f of 11, that's 121 minus 22 is 99 plus 7 is 106. So you can pull out a second coordinate point, 11 comma 106. And all they really want here is the slope. So if you look at the change in y, you're going up 96. And if you look at the change in x, you're going up 8. So change in y over change in x could be 96 over 8. And that's 12. You have an average rate of change. You have a slope. Yes, you can see slope show up for quadratic functions. You have a slope of 12. Number 3, equation of a line that's parallel to this line and passes through the point -1, 5. I love these questions. I think they're super easy. Right away, parallel, you need the same slope. That one's out, that one's out. Because it's multiple choice, you can plug in x and y and see if it works. So plugging in 5 equals 2 times -1 plus 7. Doing it down here, 5 equals 2 times -1 plus 5. Only the one in the top right here, choice 3, gives me a correct equation. This is -2 plus 7, which of course is 5. 5 equals 5. That's my winner. Or down here, I get -2 plus 5, which is 3. Does 5 equal 3? No, sir, no, ma'am. If you don't like to do it that way with multiple choice, you steal the slope, y equals 2x plus something, and you plug in your x and y. 5 equals 2 times -1 plus that something. 5 equals -2 plus b, and just solve it out, add that 2 away, add that 2 away, and your y-intercept should be 7, which again happens right there. All right, question 4, great question, asking just kind of intuition-based stuff. Nothing super exciting here, just that you should know that a line that looks like this has a positive slope, or excuse me, it doesn't have a positive slope. It has a positive y-intercept, and it has a negative slope. So which one of those does that? Okay, so negative slopes are here and here. Positive y-intercepts are here and here. So that gets my 2 check marks. That's my answer. Moving on to, oh, there's me. Go away, me. All right. All right. What is the x-coordinate of the line whose equation is y equals 2x minus 3 and perpendicular to a line whose y-intercept is 17? At what x-coordinate? Intersect a line, intersect a perpendicular line whose y-intercept is 17. That's a good question. That's a good question. Well, a perpendicular line is an exact opposite slope. So from positive 2, we're going to hop over to -1/2, and they're telling us the y-intercept is 17. So here's my real equation. Y equals -1/2 x plus 17. All right. At what x-coordinate do those two intersect? I love my calculator for this question. I'm going to grab it, go to y equals 2x minus 3, grab a fraction, negative 1 over 2x plus 17. Go ahead and graph. There's one line. There's another line. What's the x coordinate where they intersect? Second calc intersect. Binga, binga, binga. X equals 8. A little bit of setup to get this equation, but once you have it, very easy. Speed of a car in miles per hour is a linear function of time in minutes. Which of the following would be the units of the slope of this linear function? So the speed of the car is a linear function of time in minutes. Time is pretty much always x. And the miles per hour would be the y. So it's miles per hour over minute. Done. Just a reading question. Number 7, which is the inverse. Inverse, you just have to do one simple thing. You got to switch x and y. X equals 4y minus 2. And then from there, you have to solve it for y. So plus 2. Let's go up here. X plus 2 equals 4y. And divide by 4. So we've got y equals x plus 2 over 4. Now, it's multiple choice. They didn't write it that same way. I can see that 4 is supposed to be on the bottom, which it's not here. And I can see that it's not negative, which it is here. So 1 and 2 are my best choices. Kind of think of it as 1 over 4x, which is both here and here. And then 2 over 4 is the same thing as 1/2. So choice 1, your best answer right there. All right, we're going to move on again to questions 8 and 9. A little piecewise function happening here in 8. For a piecewise function, you just want to look at the slope. See that this one's going up 2 over 1. Excuse me, over 2 up 1. Over 2 up 1. And it's going to repeat that over 2 up 1. So it has a slope of 1/2 to start. And I only see one thing with a slope of 1/2. So that's really right here. We're kind of done. But just to verify, on the second part of the graph where it kind of accelerates right here, okay, kind of making that quick turn upwards, you can look at that slope and see that it goes over 1 up 3. So that's going to have a slope of 3, which is also right here. Just being able to read a piecewise function is all that. Graph of a function, and the graph is always symmetric across. This is just a fact here. The line y equals x. You might remember that from geometry because a reflection in y equals x caused the coordinate point xy to switch into yx, which is exactly what we did when we wrote the inverse equation just problems ago. Number 10, get the equation of this graph. I love it, super easy question. Y-intercept, 1, 2, 3, 4, 5, 6. We got a b of -6. How about the slope there? That's a solid point. That's a solid point. I'm going up 3 over 2. Almost too easy. Y equals 3 over 2x minus 6. Create a graph of the function's inverse on the same set of graph paper. I'm going to keep those 2 points. All right, and I'm going to flip them. This would be 2, -3. And this would be 0, -5. Flip that. -5, 0 should be on there, as should -3, 2. Okay, you want a couple more points? Here's 4, 0. How about 0, 4 being on the inverse? Okay, and that's going to be what our inverse function looks like. You might notice these are symmetric across the line y equals x. Okay? Now determining that equation's inverse, again, super easy. Switch x and y. You hear inverse, you think switch x and y. So it's going to be x equals 3 over 2y minus 6. Still got to solve it out. Plus 6. 3 over 2y equals x plus 6. And the best way to deal with that fraction, I find, is to multiply by the reciprocal, 2 over 3, and times 2 over 3. All right, so y equals 2/3 x, 2/3 times 6 would give you 4. And you can just check that against your red curve right here. The red curve had a y-intercept of 4, and it has a slope of up 2 over 3. So pretty perfect right there on that question. All right, 2 more. Number 11, tell how you found the value for k here. How to find this value for k, I think it's simplest just to write the equation of the line. So I'm going to pick 2 easy points to work with, 4, 9, and 14, 44. I'm going up 10 in the x direction, and I'm going up 35 in the y direction. So my slope for this line is y equals 35 over 10 x plus something. If I want to make that a little bit nicer, I can simplify 35 over 10 into y equals 7 over 2 x plus b. And to figure out this b, I just need to plug in something for x and something for y. I'll do that with, how about 4, 9? This is nice and easy to work with. 9 equals 7 over 2 times 4 plus something. 7 over 2 times 4, you can do that in your calculator. I'm not going to waste my time. It's 14. 9 equals 14 plus b. And when you subtract, you'll find b equals -5. So use that to round out your equation. Here's the equation of this line. Y equals 7 over 2x minus 5. And then if you want, you can use your calculator. Y equals 7 over 2x minus 5. Minus 5. And on the table, when x is 12, k would be 37. All right, so that k value, a little bit of work, but k would equal 37. Write the equation of a line passing through these 2 points. I'm going to skip this question because I basically just did it. Find the slope. Okay, we're going up 10. We're going down 25. 10 over -25 is your slope. You can simplify that down to -2/5, and you keep working away until I'm done with it. And last one, number 13, asked you to do high school basketball game. This is a piecewise function. Cars are going to park lot at a constant rate, 28 cars per minute, with a starting of 922 cars. Most popular equation I saw was y equals 28x plus 922, which is really good, except that the number of cars should be going down. So if the number of cars is going down, this 28 has to be negative. That's a great equation. Plug in for 10, -280 plus 922. What do you get there? 642? 642 cars. Okay, I already did the formula right there. If you want it in terms of n and m, the number of cars is going to equal -28m plus 922. And the last part is really the interesting part. After 25 minutes, the rate at which cars leave rises to 34. How many total minutes would it take? Well, let's do the 25 minutes first. Using this equation for 25 minutes, y equals -28 by 25 plus 922. That is going to give us, I want to say the answer is 222. I'll just check it. -28 times 25 plus 922. 222, yeah. So there's 222 cars left at this point. All right. And now it rises to 34 cars per minute. So your new equation is y equals -34. That's how many are escaping. X plus, well, this only starts after 25 minutes after this happened. So it's only these cars remaining, plus 222. You got to figure out when they're all gone, so that's when the number of cars will equal 0. -34x plus 222. Subtract 222, divide by -34. So 222 divided by 34 gets you 6.5. All right, or x is 7 minutes. Reading, understanding, using all pieces of the question. There was 25 minutes up here. There was 7 minutes over here. It takes a total of 32 minutes. 32 minutes for everyone to get out of this parking lot. It must be a very big high school with a very popular basketball team. All right, thank you guys. I'll see you tomorrow in class, and we will do some more work.